Now, when to use each protocol, if you understood what I said before, it should make a lot of sense what I'm about to say next. So Radius is mainly used for network access, like it's used to authenticate users coming in via VPN, via wired authentication, or via Wi-Fi authentication, because TACACS Plus does not support translation of EAP over LAN packets for authentication. So you cannot run .1x and have TACACS as an authentication protocol, because TACACS cannot translate EAP over LAN into TACACS. And TACACS does not support common network access authorization attributes. Like if you use TACACS as your authentication method, TACACS cannot return over SGT or MACsec or split tunneling policy as authorization attributes. So that's why primarily Radius is used to authenticate, authorize an account for network access requirements via VPN, Wi-Fi, or wired connection. And like guys, TACACS is mainly used for device administration, because Radius does not support command authorization and command accounting. Of course, it could support command accounting, but why should we add command accounting support to Radius, since we have a dedicated protocol like TACACS which does that built in? And then Radius does not support command authorization, because Radius does both authentication and authorization at the same time in one step. So for that reason, it cannot work with command authorization, which we may need to want for device administration. So based on how it works, that it does both authentication and authorization at the same time, it makes sense that we cannot do command authorization with Radius. Because as I said, how command authorization works, as you're going to see in a couple, is that router 2 telnets over to router 3. Let's say SSH over to router 3. It sends username and password. 3 relays those username and passwords over to the ACS server via TACACS. And the ACS is going to say, okay, authenticate it. Which means now router 2 is connected to router 3's VTI line. But now when router 2 wants to type any commands to router 3, so 2 is now connected to the VTI lines of router 3, and the user, which let's say user of X which got connected, wants to type in a command of show clock. At that point in time, router 3 is going to send a request to the TACACS server saying, is user of X allowed to type in that command? And if ACS says okay, then the command is going to work. If the ACS says not okay, then on router 2's console you're going to see a authorization failed message, which means you're not authorized to send that command. Because if the ACS server says not okay, router 3 is going to send over to router 2, not okay, you're not allowed to type in that command. And you see on router 2 authorization failed message. So as you can see, because the authorization is done per command, it makes sense that Radius does not support this. Because Radius, to perform authorization, it has to also perform authentication. It does both steps at the same time. It's not a separate process in Radius. So the reason I'm saying all of this information in there is because it has to make sense. I want to let's say make you understand that whatever you learn, it has to make sense. It doesn't make sense to go out and read a document and state Radius doesn't support this, TACACS doesn't support that. You always have to understand why, because if you understand why it doesn't support those features, again, you don't have to remember them, because they make sense, they are logical, and it's going to stick up with you. You don't have to constantly memorize it or constantly reread it to remember what's supported and what's not supported. Now, AAA for device administration. So authentication and authorization can be done either locally using the local database of users on the device or remotely via TACACS Plus or Radius. As I said, in general, we're going to be using TACACS because if we want to do command authorization, which is likewise what we want to do in production network, Radius does not support that. Both methods, local and remote, can be used at the same time for redundancy. So as you're going to see, we're going to configure authentication authorization via the remote server with a fallback on local, so that the connection with the remote TACACS server fails, we're still going to be able to authenticate and authorize users against the local database. We have two types of authentications. We have a login type of authentication, which allows access to user mode, and enable type of authentication, which allows access to privilege mode. So I hope everybody at least is aware of that. So user mode means that if I say router 1, I'm in user mode now. Which means if I say show privilege, I have a privilege level of 1, which means I have access to a limited set of commands in here. Most importantly, I cannot access configure terminal. I cannot configure the router. To access those commands, I gotta say enable 15, which means privilege mode. And now I'm in privilege mode, I can say okay, configure terminal and do configuration. So for that reason, we have two types of authentication. Login authentication to get to user mode, and enable authentication to get to privilege mode. We have two types of authorization, possibly. Exec authorization, which allows access to shell, which means to the router's VTI line or the console, and assigns also the privilege level. So via exec authorization, we're gonna receive shell access, and we're gonna get assigned a privilege level from the TACACS or Radius server. And also it can perform command authorization, which means once we are on the router and we have access to pretty much all commands, which of those commands can a user actually use to configure that device? And of course, accounting can only be done remotely via the TACACS Plus server, so Radius does not support that capability, and local accounting is not supported via AAA. There is a workaround for that, but it's not commonly deployed. So counting has to be done remotely via TACACS Plus to keep track of which user has done which commands on the router in there. Now the privilege levels. So each command has a default privilege level assigned, which of course it can be changed. And the default command privilege levels are going to be 0, 1, and 15. Now when a user connects to a device to manage it, and it gets authenticated and authorized, it is going to get assigned a privilege level via authorization. And that privilege level is going to grant access to specific commands. So as I showed in here, once by default the console doesn't ask for authentication, so I am at the console, but because I got assigned a privilege level of 1, it means I cannot access commands at level of 15, because by default all commands have a level of 0, 1, or 15. With a level of 1, I can only access commands with a privilege level of 0 or 1, but not higher than that. So once I get authenticated and authorized via the authorization exec process, I'm going to get assigned a privilege level, which grants me access to some commands. Okay, before we go to the implementation part, there are a couple of questions in here. So from Piyush, we use same MPF for filtering traffic from one interface to another interface, like inside, outside. So we talked about MPF in the CCNA class. MPF, it's, as the name states, a modular policy framework, which to call it simple, it means that being a framework, it has a lot of capabilities. Which what that means is that anything which is special on the ASA file is going to be done via MPF. Like if you want to redirect traffic from inspections to the IPS module, to the CX module, to the firepower module, is done via MPF. If you want to do net flow gathering, is done via MPF. QoS is done via MPF. What else? Inspections, advanced inspections of the protocols is done via MPF. So pretty much everything which is advanced, it is done via the MPF framework. So I'm not sure, Piyush, what to say by we use same MPF for filtering traffic from one interface to another interface, like inside outside. I'm not sure what you mean by that question. Please rephrase it and let me know what you mean. Because we have only one service policy globally applied, which means that whatever we have defined in that policy map, so this policy map is applied globally, which means that all traffic globally, meaning all traffic flowing through the ASA, doesn't matter on which inbound interface, on which outbound interface, is going to get affected as configured in that policy map. So that's what it means. I have applied this policy map globally, which means all traffic flowing to the ASA, doesn't matter the ingress interface, the egress interface, it is going to be inspected per my configuration in there. Now, of course, if you look on the CISCO's documentation, based on the protocol, MPF, CISCO SA MPF, I'm looking for a list. There we go. Looking for this list. So, for example, this is what partially we can do via MPF. Application inspection, traffic evaluation to the CX module, to the IPS module, net flow, QoS, advanced TCP inspections. That's what we can do pretty much via MPF. Now, based on how you apply that policy map, if you apply it globally, it means that based on the type of based on what you do with MPF, like for example, if you speak about application inspections, it applies only in the ingress direction of any interface on the ASA, and it makes sense. While if you apply that policy map per interface, and in that policy map you have defined, let's say, only application inspections, it means that if that policy map is applied at the interface level, it's going to affect traffic bidirectionally going through that interface. So based on what you do with MPF, and how based on where you apply the MPF per interface or globally, it's going to affect traffic in a different way, either bidirectional, out of ingress, out of egress. So again, Piyush, let me know exactly what you meant about that question, because it was not clear to me. Okay, other questions till Piyush replies. So question from Matthew. Christian, can NetFlow collect things like IPSLA statistics? So it depends. The SLA statistics can be gathered, as far as I'm aware, via NetFlow only if you do also CCNP integration from the NetFlow collector to the managed device. Like, I'm not 100% sure, but I think that is the use case. So if you wanna gather IPSLA statistics via NetFlow, I think you need SNMP for that. Net flow SLA statistics via SNMP. Let's do this. IPSLA statistics via net flow. Maybe find something in there. IPSLA and net flow. So since that flexible net flow may support that, so before flexible net flow was an option, it was required via SNMP. So you can monitor IPSLA with flexible net flow, that's supported. So it means that you need version 9 of NetFlow. In version 5, you had to do integration with SNMP. So you had to read via SNMP the MIBs of the SLAs. That was a requirement. But in version 9 with flexible NetFlow, you can actually monitor the SLA statistics in there. Another question from Matthew. How would the device authenticate if it was using a WAN and PPP, for example, to the authenticator? So to quickly answer that question, it means that if we go back to, let me open up in here another diagram. So for example, if this would be a serial link between router 1 and router 3, let's say. It was a serial link and it was using PPP. And this would be my client, PPP client. This would be my server. First of all, of course, you have to understand what kind of authentication do you use via PPP. PPP support, so the server is going to authenticate a client via PAP, via CHAP, or EAP. Regardless of those, so the protocol doesn't matter really. In the end, what's going to happen is that the client, which is the supplicant, so this is going to be the supplicant in that A model, and this is going to be the authenticator. The supplicant is going to send the credentials to router 3. And then router 3 is going to send those credentials over to a radio server for authentication, this being the authentication server. So that's how it's going to work. Of course, the server can authenticate, the PPP server can authenticate the PPP client via local database, but optionally can validate the provided credentials from the client through a remote radio server.